I run myself as Lakshminarayan. Now we talk about the applications of PDE, that means partial differential equation. Partial differential equation are widely used to study how heat flows through material. The most common example is the heat equation, which tells us how temperature changes with the time and the space. For instance, if you heat at one end of a metal rod, the partial differential equation will describe how the heat spreads through the rod until it reaches the equilibrium. And this concept is crucial in engineering and construction and also even climate studies. Thank you.
My name is Green. I am going to explain the wave motion function. Another important application of PDE is in wave propagation. The wave equation models vibrations, sound waves, light waves, and even waves on the string. For example, when you plug a guitar string, the vibration that produces sound can be displayed by PDEs. In physics, it helps us understand how energy transfers in the form of waves and whether in water, air or space.
Good morning to all. I am R. Naveen Raj, second year mechanical engineering. I am here to explain the applications of partial differential equations. The main application of the partial differential equations is fluid flow. Fluid dynamics is governed by a set of partial differential equations known as Navier-Stokes equation. This equation explains how the liquid moves and also how the gases are moved. They are used in weather forecasting, designing airplanes, studying ocean currents, and even in medical fields. Science to model blood flow. Without partial differential equations, we couldn't accurately predict or control fluid motion in real-world application. Next topic will be continued by Karthik.
Hi everyone, I am going to explain the application of PDE in quantum mechanics. At the microscopic level, the behavior of particles like electron is explained using PDEs, particularly the Schrödinger equation. This equation helps us calculate the probability of finding a particle at a certain position. Application range from atomic physics to semiconductor design, and it is the foundation of modern electronics and nanotechnology. Thank you. The next topic will be explained by Tanushree.
Hi everyone, I am Tanushree. I am explaining about the electromagnetism. PDEs are also at the heat of electricity and magnetism, especially Maxwell's equation and Laplace equation. These describe how electric and magnetic field behaves. They are used in designing electrical circuit, communication system and antenna. Without PDEs, technologies like Wi-Fi, mobile phone and radar would not exist. Thank you. Next topic is concluded by Karthik.
Hi, I am Karthik from Mechanical Engineering. I am now going to present about heat conduction and diffusion. One of the earliest and the most celebrated uses of PDEs is in modeling the flow of heat. Joseph Fourier, in the early 19th century, derived the heat equation, a second-order linear PDE, to explain how temperature develops itself in a solid body over time. The equation links the rate of change of temperature at the point up to the curvature of the temperature profile in space, reflecting how the thermal energy spread from hot region to colder ones. Spread from the hot region to colder ones, the equation is not limited to heat. It also derives the diffusion of particles, chemicals and pollutants in gases, liquids or pronounced material. Engineer uses solutions of the heat equation to design effective cooling system in electronics, to study underground heat transfer in geothermal plants, and simulates the spread of contaminants in soil or groundwater. In essence, whenever there is a provide involving the gradual equalization of equality through a medium, the heat of diffusion equation and partial differential equation provides the mathematical framework. Thank you.